Okay, so good afternoon. We are going to try this first test video on this problem, and of course it's gonna not stay zoomed. Hopefully that'll stay in there. Okay, so this is like problem number 15 on 1.7, solving inequalities. And I thought this one, we didn't really get to cover this in class, so I thought this might be useful to you. So first of all, remember we're going to solve it as if it were an equation to find our boundaries. Our critical values is what some people call it, because this is a cubed, so you can expect 3 solutions out of this. Sometimes they may be the same solution, but there will be 3 of them. And we're going to factor a common factor of x out first. And I get x times 9 minus x squared. And then, if you'll recognize, this is the difference of 2 squares. So I have a perfect square and a perfect square, which means it factors into 2 binomials. So you got 3 minus x and 3 plus x equals 0. So if you want, you can go over here to the scrap paper and you can multiply this out and see that it'll come back as 9x minus x cubed is greater than or equal to 0. So what makes this equal to 0? Well, right here, so now I don't just have 2 terms that multiply to be 0. I have 3. I have this one, and I have this one, and I have this one. So if x is equal to 0, then that would cause the whole thing to be 0. If x were equal to 3, it would cause the whole thing to be 0. And if x is equal to negative 3, it would cause it all. So that gives us our 3 critical values or boundary values. And so it will be, we're going to check the interval from negative infinity to negative 3. And because the original was or equal to, I'm going to use this. And then we'll check the boundary from negative 3 to 0. And then we'll check the boundary from 0 to 3. And then last we'll go 3 to positive infinity. Now, we've got to pick a test value in each one of these areas. So here I'm going to choose negative 4. And here's what really stinks. My favorite number, unfortunately, is one of the solutions. So that means we don't get to use it. So I'll choose negative 1 here and 1 there. And we'll choose 4 there. So check it, remember, in the original inequality. So I have 9 times negative 4 minus negative 4 cubed. Is that greater than or equal to 0? So I get negative 36 minus 4 cubed, which I believe is 64, but it's negative 64. And is that greater than or equal to 0? So subtracting a negative is the same as adding its opposite. So negative 36 plus 64 is 28. Unless I did that wrong, which is greater than or equal to 0. So this one is a yes. And we'll do the next one. I put negative 1 in. So I have 9 times negative 1 minus negative 1 cubed. Is that greater than or equal to 0? So I get negative 9 minus 1 cubed. Negative 1 cubed is negative 1. And then subtracting a number is the same as adding its opposite, so I get negative 8. It's not greater than or equal to 0, so that one's a no. Then we'll try 1. So 9 times 1 minus 1 cubed is 9. Minus 1, is that greater than or equal to 0? 8, and so the answer is yes. And I ran out of room, so we'll cram it in over here. 9 times 4 minus 4 cubed greater than or equal to 0. So we get 36 minus 64, which is negative something, I'm sure, which is not going to be greater than or equal to 0, so that one's going to be a no. So we will have that. So our two solution sets are those two. So the solution then when you type it in will be negative infinity to negative 3 and union with 0 to 3.